everyone. Welcome to week 8, lecture 2. Welcome back from yesterday if you were here yesterday. Or welcome if it's your first lecture of the week. Stream delay seems to be a bit faster than usual. That's good. You all said hello very quickly. And hello back. Who was saying they have a 100% attendance rate? It's pretty impressive. How are we all going? Good? Anyone have a chance to look at the lecture code from yesterday and have some play around with it? Stream sniped. What does that mean? Well, I know what it means, but who sniped me? I think I know what it means. Anyway. Okay. What are we doing today? Well, we're going to look at multi-file programs, but I wanted to put a couple prefaces on this. First of all, let me fix this up. Okay, it should be like that. Oops. Yeah, we'll do a Kahoot. I'll make one up nice quickly during the break. Yeah, how'd you go with it, Nicole and Bobline? No, not the whole thing isn't non-examinable. Just the very last part, please. Be careful. just the final section. I made it very clear. Only things that are in that unexaminable file. Everything else is examinable, and there's nothing really big in there. You all signed the waiver. That's right. I've got the evidence, the proof. Okay, so today the content is examinable. However, with a caveat, so you will not need to write multi-file programs in. So you won't have to submit multi-file C programs in the labs or the assignment or the exam itself. So you will not need to write multi-file C programs and submit them. However, the idea of multi-file programs, the concept of multi-file programs is examinable. Does that make sense? So we could ask you questions about it in the exam, right? The concept is examinable, it's in the course outline, but we're just not going to ask you to put together multi-file programs and submit the separate files. Does that make sense? So, and the reason for that isn't just because, the reason for that is the idea is so extremely useful. So, yeah, rating A, examinable content, the highest rating of all. So the concept is super useful, so you will find it useful, I promise. It's just that, so just so you know, don't spend hours and hours like practicing it. Well, you can, but it's not going to be that you have to submit the files in the exam. So there's non-code writing questions in the exam. Yeah, so all the practice exam stuff, don't worry. We've got not only do we have practice exams, like we updated the practice. We'll update the practice exam for you. We will talk about the format of the practice exam. We'll talk about the format of the exam. All of that will be covered in an upcoming lecture, I promise. The exam's almost written. It should be good. Well, good for me, maybe. Not really. I'll be around all day and marking it for days after. But yeah, so don't worry though. We will more than prepare you for the exam, I promise. Don't stress about the exam. Don't stress about anything, but focus on the concepts, doing the work, understanding it, and you'll be all good. The exam is on the 12th of August. That's already published, everyone. August 12th. Can I guarantee the time? Yeah, 1 p.m. is when it starts for most of you. Is that news to everyone? Maybe we'll need to put it. It just got confirmed, so. So, good question, Will. How many hours is the exam? You have 6 hours for the exam, and I know that sounds incredibly long. It's a 3-hour exam. but you have 6 hours to do it. So we have not written an exam that should take you 6 hours. We've written an exam that should take you 3 hours, but because of things like, internet issues and timing and servers, we're giving you double the amount of time that you should need for it. And it's completely normal to use extra hours. So you don't have to feel bad if you do use the extra hours. Not that I think anyone will, but, so there's no 3 hour timer. So there's a 6 hour timer, but it's a 3 hour exam. Make sense? But don't worry about it. Well, worried about it a bit. Okay. Let me quit this. I don't want this application open. All the systems, we'll explain it all in the upcoming lecture. Okay, I didn't want to talk about the lecture all. Okay. If you're an ELP student, you will be contacted by us regarding your considerations. Do not worry about that. What are the mixed messages, Dorian? Let me know. I can clarify. Oh, mixed messages on. Worry about it. Don't worry about it. Worry about it a bit. Well, you want to. This is the thing, right? There's negative stress and there's positive stress. You want some positive stress. Was it eustress? Is that right? You want some positive stress to get you motivated, but you don't. I don't want you to beat yourself up over it. That's my mixed message. Hopefully my 1511 messages are less mixed, but you guys can let me know. So any advice for finals? My biggest advice for finals is don't focus on the exam, focus on the content throughout the term. That's the biggest advice. So basically what I'm saying is, like all of you here should be doing, focus on committing this stuff into your long-term memory by practicing it throughout the term. That means once you get to the final exam, it will come to you. 1511 comp courses, this may be your first proper exam outside of high school. High school exams, a lot of them are based around rote learning, depending on the field. University exams, or at least the ones that we write, are more about how well you understand things, right? And that's what we're trying to understand. And the way that you can show that you understand things is by committing it to your long-term memory. But it's not a crazy exam. And do a lot of people fail this course? No, very few. It's very likely that if I recognize your YouTube names like I do with Windows, then you're not going to have any problems with the 1511 exam. It's open book. You have the internet. I mean, really, that is a big help. Open computer. The color coordination. Yeah. We got the UNSW yellow. Yes, Bonrick, of course. Bubbly and Matthew, Windows. If you're coming to the lectures, you're good. And if you're watching them too. I know some people just can't make them. Okay. All right. That's enough. I will talk about more details of the exam in the exam details lecture, I promise. But what I want to say is you'll be okay. You're not going to fail. You won't fail. All right. So once again, multi-file programs. You won't have to do them in any accessible content. However, they're extremely important conceptually, and I think you'll find them interesting. Are we good to get into them? They said that last time. When have we failed you yet? In 1511? Okay, that should say week 8, but you know where to get the lecture code by now. Don't worry, we'll have some more prep talks coming up. Okay, so what's going on? What are multi-file projects? Okay, what are they? So far, if we look at the programs we've been writing, here's the one that we were writing yesterday in the lecture. All the code for the program is in one file. All right, there's 318 lines in this file. All the different functions, the variables for those functions, the prototypes for those functions, the structs for these functions, they all exist in this one .c file called, in this example, linked browser history, right? That's standard. This is what you've been doing all term. But what we can do is separate our programs over multiple files. So rather than all being in one .c file, we can separate, create multiple files, put our code, sort of logically separate these files and programs source code into these files. And that gives us a few benefits. So number one, the files are shorter, right? So there's less things we need to read when we're reading a file. There's less going on. So they hopefully are easier to understand. When you are separating code into multiple files, you can separate it with some sort of logic. So let's say in this program, this is the linked list. Let me give you a good example. In the browser history code that we wrote, there's some generic linked list functions, right? Agreed? Like inserting a node, deleting a node, blah, 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 blah. And there were functions specific to this web browser program, like printing a web page, reading a web page, things like that. So we can separate. So that's one logical way of approaching how we can separate into multiple files. So we could have the webpage.c file and the linked list.c file. Yeah, let's move on from the exam talk. I know everyone is thinking about it, but we'll get there in the exam prep lecture, I promise. So does that make sense? So that's one logical way that we can break down the structure of this program. We have the web-specific functions, like history, go forward, go back, and we've got the linked list specific functions. And that's a logical way of separating the program. So that if you wanted to look at this program and you wanted to say, I really want to read how the linked list is working, you could go to the linked list file and find the functions you want. If you want to understand how the web-specific stuff is working, you can go to these functions and you can understand how they work. Whoops. And by having that logical modular separation, again, the programs should be shorter, they'll be easier to read. And we can write and test these separately too. So that's the concept. You've actually been using multi-file, well, let me rephrase this. You've used other C files, okay? Anytime you have an include statement, this include something.h, you've loaded another C file, okay? And we call these libraries. So these libraries are just more C files. In fact, we can open these files, right? So VS Code can deep link include. So I'm holding command, I click the file name, and now I'm reading, you can see it's mostly comments, but now I'm reading what's going on in this C file. Well, this is a header file, and I'll talk about header files. But if we go, okay, they separate them completely, so it'd be hard to find the actual implementation file. But so these files, you can see, come with GCC, which is the compiler I'm using. It's the same for you. And these look like there might be ones written specifically for Darwin, so Apple computers on a 64-bit machine. There could be different variants too, depending on your operating system. Yeah, it looks, I mean, yeah. Well, this is actually quite a small file, but yeah, there's some weird stuff going on here. That's not the point of today. But the point of today is that you've been doing this. So you've brought in functionality, obviously written somewhere in some other file, and you've been using it anytime you call those functions. And we've been including C standard libraries. So what this means is that we've only, and we sort of should know this, we've only been bringing in files that come from the software development kits or the standard library written for the C compiler. And again, what's interesting is that the interface for all of these includes are the same. However, they might actually be slightly different depending on if you're on a Mac or a Linux machine or, God forbid, a Windows machine. Then you got bigger problems. I'm sort of just kidding. So anytime you see Darwin, for example, this is specifically referring to Apple computers. Mostly legal jargon. Yeah, that's Apple for you. Yeah, okay. So that's really cool. However, you can obviously also include C in header files that other developers have written or that you have written. Tammy's on a Windows machine. Well, all the best. No, I'm kidding. Sort of. Okay. Any questions about what we've covered so far? We've got a bit of time this lecture, so if you've got questions and things like that, you can let me know. I'm joking, by the way. There's nothing wrong with Windows machines, but... Actually, WSL is really good. So if you use WSL, Tammy and Bonrick, then I'll allow it. If you don't, you should look into it. Can't run Valorant. Okay, well, I have a Windows machine. I have a Windows desktop right here. So I understand you just spend lots of money and tell both. Use both. Okay, final exams online. It's remote. Okay, no more exam questions. I promise we'll have a whole lecture on it. Okay, any questions on this stuff? While I have more green tea. Okay, AR11, I'll answer that question in a moment. There's nothing really wrong with Windows machines. They're just not Unix compliant. So they have a lot of different development tool sets and things that I don't really operate with. That's all. I'm just joking. They're great for like C++ development in Visual Studio. Okay. So like I said, you can include your own files as long as you've written them, which allows us to join different libraries or different code together. Allows multiple people to work together. Sure, you could do that in one file or across multiple files. Okay, this is the key thing. So the big thing with multi-file programs, so there's two aspects to it. There's two aspects to it. The first aspect is to logically separate larger programs into multiple files to make it easier to read. That's one thing. The other thing is being able to write libraries, functional libraries that you can use that are useful in multiple projects. For example, linked lists are super useful. They're super useful in multiple contexts. Our web history, or whatever it is you might be doing where you need a linked list. Doesn't make sense to write an implementation for linked lists every time you want to use a linked list. The answer is probably not, but not necessarily always no. So you can include a linked list library, for example, and use that in your functions, in your programs. And then you don't have to worry about, okay, well, I want to build a web browser, I have to build a linked list, and then, we need to reuse things. That's how we make progress in software engineering. WSL is the subsystem that lets Linux run on Windows machines. You can't use multi-file projects for Summon 2 only because we don't have a way to submit it. We didn't set it up for submission because they're not mandatory. All right. So what have we got here? Okay. So we need to talk about this .h business and this .c business. If you've been paying attention, we include .h files, but we never write .h files. We only write .c files. And that's sort of, what's going on with that, right? So does anyone want to tell me what they think or what you think is going on with these .h files? The .h stands for header files. Yes, that's what it stands for. But what are they? What's going on with them? And can someone, if we look at this header file, can someone, point out something that they notice about these files? Not the pointers or the linked list. So this is just the string header file. It's something special, sort of, yep. Header files don't have main functions. That's exactly true, but that's not exactly where I'm getting at. Okay, defrag. Header files just contain function prototypes and struct definitions, right? Absolutely. 99% of the time. So the header files are actually the designated place where we put the prototypes or the definitions of what the accompanying C file will have functions for. So another way of saying that is these prototypes usually go into a header file of the same name as the C file. Okay? So this string.h file contains all the definitions of what the string.c file will have in it, but it does not actually have any implementation. It does not say how to do anything. Do we see that? There is no open bracket, do this, if this, blah, blah, blah. It's just the prototypes. And so usually you don't see things like these prototypes in the C file. It's not to save memory, and I'll talk a bit more about the memory and all that stuff in a moment. How can you have the function prototype without the function itself? Great question. That shows that you're thinking, and I'll sort of explain that in a moment. Do we put hash defines and include or other includes in the header file? You can include, yes, other header files in header files. Yes, is the answer. But I'll speak about it in a bit more detail in a moment. Okay, so the header files okay, here's another way of saying what's going with the header files. The header file is a promise of what the accompanying C file will have functions for. It is a declaration that, hey, strings.c will be able to do all of this stuff. Therefore, if you come across a function called this, I promise I will have a function for it. Now, why do we need to make this promise? That's because when we compile multi-file programs, the compiler goes through these prototypes and it's like, okay, I know that there's going to be a create node function, a print linked list function, and insert at end function. So if I see a function that calls one of these functions, I know that at some point it should be coming into my compilation. Yeah, it's basically the header files are saying, trust me, bro, I promise that when you compile all the C files, the function's going to be somewhere. If it doesn't actually appear, you'll crash, you'll have an error. So if you don't actually have the functions, you're in a bit of trouble. So Betsy, it is exactly like writing the prototypes above main. It's the exact same thing. The reason we wrote these here was to say, hey, Mr. C compiler, or Mrs. C compiler, we don't know, or however they like to be referred to, I promise I will write an insert at end function. I promise I will write a print linked list function. So that when we start at main and it calls print history, we've already promised that there will be a print history function. And all a header file is a place where we can put these prototypes. That's really it. We've already introduced the idea of why we need them. It just lets us take them out and put them in a header file. And it's just neater when we have a lot of functions. Absolutely. Yeah, exactly. Jacob, you're saying that if we have our function prototype without the implementation, it will crash. Why does our program work when we don't use every function yes, you've got it slightly the wrong way around. It's if we call a function that doesn't have an implementation, we will crash. Not if you don't call it. So it's not if you have the implementation. It won't crash if you have a prototype without the implementation. It will crash when you call a function without the implementation. Not if you don't call it. If you never call it, it will never try and it will never fail. It's just calling a function that doesn't exist. But what you've done is lied to the compiler. So let me try to explain this again, right? If I remove, let's go to main, and my structure in this file is a bit stuffed up. Print history. Print history is up here. Okay, there's another caveat to this, right? One more thing I should say before I go down this line of thinking. So when the compiler comes across a C file, it starts at the first line and it analyzes it line by line. So it comes through and it says, okay, here's some includes, here's a struct, here's a struct, here's a struct. Here's a prototype. Okay, I know this program is going to have a create node function. Here's another prototype. I know this program is going to have a print list, so etc. comes down. Then it gets to main, right? It looks for main, but as it's coming down, it's learning what it's remembering what the program's got. Oh, I know this program has a read page function, and it's the actual implementation in this case. Oh, I know there's a print history function. So when it gets to main and it gets called, okay, I already know it's there. If we move print history to below main or below where it's called, what's going to happen now? So we come down, we get to main. Has it analyzed a print history function yet? So you think it will work. Keep in mind, I should mention, we have not defined its prototype. Well, let's just find out. Okay, we get an error, and it's telling us print history is invalid in C99. I do not know what this function is. Okay, so, but maybe I don't want to move the function around. How do I tell it that print history will exist? I can define the prototype. So I've made the promise. Remember, the compiler's coming down line by line. It learns there's a print history function, so that when it comes down to it in main, it's like, okay, don't worry about it. I won't get angry. You've promised there'll be the print history function, and so we don't get an error. Then when we actually run the program, the implementation gets copied in. So that's just one thing you've got to keep in mind. So the prototype needs to be declared either in the header file or in a prototype in the C file, or the implementation needs to be above the caller. Whew. Okay, Gabe, you ask another fantastic question. +1 to Gabe, 10 points to Gryffindor. Could we not directly include a C file with the definitions and implementations instead of just a header file? So we can. The reason that in C, the implementation and the declaration or the header files are separate is for optimization purposes. So it's quicker for the linker to just scan the prototype. To just scan the prototypes without needing to scan through all of the implementation, because it has to read it all line by line. So it's just an optimization process to speed it up. However, in more modern languages like Python, Java, C#, JavaScript, we do not do this. You do not separate your header and your prototypes and your implementation across separate files. It's really only still done in C and C++. More modern techniques were developed, processes got faster. We no longer have to screw around with it in more modern environments. And you will come to appreciate that we don't need to, because it is quite annoying having to do all this. So the distinction between the header and the C files. Header files only include prototypes or definitions. The C files include the actual implementation, the actual instructions to compute. that belong to each function. So by having the header file, it doesn't have to individually process each function. Exactly right. It just needs to process that the presence of the function is being promised. It doesn't need to go through all of this code that would be unnecessary. And again, in small programs, this isn't a problem. It's in really large programs, it speeds things up. It's hard to visualize everything you're saying. Yeah, I get that. Maybe I can draw a diagram in a second. Okay, well, here's the header file. Here's the slide on header files. So header files typically include the function prototypes for the functions that implemented in its implementation file, and comments to describe how the functions work, any hash defines. It basically describes to the programmer and to the compiler everything that this file will be able to do and can do. It does not execute any code in the header file. There's an asterisk there. Not something we need to cover in 1511, but basically this slide is true. It's like the definition file. Can we just include a .c file without the header? I always do that in C++. Perhaps you can, but it will really slow down your compiler in larger programs. Clarification on the asterisks. I have seen some header. I just have a memory of writing header files that had some very basic implementation in them, but I can't remember the context. But we don't have to. You can Google it if you're interested. Yeah. Look, most things in computing have a asterisk. There's always an exception. So does the stdio.h file have a large header file with all the function? Yeah, absolutely. And we can look at it. We can look at it. This is the standard io.h file. There's a lot of documentation. We can see it's just hash defines, more hash defines, and then prototypes. That's it. And some macros, so you can have ifs. We've not covered these either. That looks nuts. I don't know what's going on here. This has been tuned to generate reasonable code on the VAX using PCC. Thanks, Apple, or whoever's written that. That's pointer arithmetic stuff here. But see, this is what I'm saying. I mean, this is, if you look, this is actually implementation. There's an assignment statement here, and this is in a header file. I don't know what PCC is, but this is what I mean. 99%. This is just implementation. This is just prototypes. This is standard.io.h, Daniel. So this was written by someone. Either at GCC or at the C, whoever's writes C, or at Apple. The actual functions are stored somewhere else. It'll be somewhere in the GCC directory. But look, don't worry about those. Those are very complex, arcane examples. We will do some with our own, and it'll be a lot simpler. Like Tammy has said, we'll just be compiling with the header files and the C files in the file. And yeah, you could edit those, Daniel, but it's warning you not to. Cool. All right, so that's the header file. Yeah, and header files are linked to a respective implementation file. That's exactly right, Bonrick. What's the implementation file? Well, you've been writing these all term. It's where you write what you actually do in the functions. If this, do this, assign this to memory, call this function, get the result, do this. I mean, that's all just in the C file. Anthony, the header files, we will be storing them in the same directory as the C files. Okay, then we have usually a main.c, which has the main function in it. Because like I said, you can have multiple C files. Here's another example, although I've just been showing you one. So we have main.c. So this is our main program that we wrote. We include maths.h, right? We always include the header files because you don't want to scan all the implementation at that point. The header files says, okay, I can do square, I can do sum, things like that. And then when it actually compiles it, we compile the C file, which says, okay, here's how to square, here's how to sum, etc. How are the header files connected to the implementation file? The implementation file includes its header file associate, let's say, and usually they have the same name but with a different extension. Maybe Tammy or Noah or Patrick can remind me. I think it's because they have the exact same name. That's how they're associated. Is that true? But the link from C to header is because C includes maths.h. So I don't actually think it does care about the name of the file. It's just that the header file, the C file needs to include its header. They're two sort of separate processes, compiling and running. I'll explain it all when we build it out. Okay, then how do we compile it? So when we compile, we actually only include the C files that we want to compile together. So if you've got a maths.c program and a main.c program, you just list them both after the call to the compiler. So DCC or GCC, program1.c, program2.c, and then the rest is the same. -o to maths, then you run it and it just works. So you just list any C files you have in the project, and it's nice and easy. Oh, good question, Anthony. Great question, Anthony. Okay. Very, very good. Angle brackets are used for standard library includes. So this is used to denote that the include is coming from the compiler or the operating system. Double quotes means it's my own header file, or it's something that I've downloaded from somewhere, or that someone's given me, or that I've written. So custom header file, C collection header file. That's what the difference between the braces and the double quotes means. And it could have an impact on how it tries to find that header file. Because keep in mind, like stdio.io.h does not exist in the file structure. Like I don't open stdio.h in the folder. So the angle brackets means, hey, you may need to look for this somewhere on the computer. That's exactly right, Bubbling. We just say, hey, I want to compile these C files. It goes off and finds the header files, links it all together, does the pre-processing, compiles it, and then you're able to just call it. Okay, that's all the slides. Let's get writing. Let's do a really simple example first, and then we'll do a bigger example. Okay, so let's actually make, you don't compile the header files, no. They get included and analyzed at the linking stage before compiling, actually. All right, so I'm just gonna make a multi-file directory. Let's call it like this. CD to multi-file, and open this in code. All right, so we have this folder called multi-file. Let's make a main.c file. Let's make a math.c file, and let's make a math.h file. So what I'm basically saying is I won't need a header file for main.c, although you could have one. But I want this math.c where I'm going to list some math-related functions, and I'm going to have this math.h. So I've got these 3 files here. So I think this will visually explain it if that's how you're better off learning. All right, let's work on math.c first. So the compiler, so Bubbling, the compiler is given the prototypes because they're included by the C files. So the first thing we need to do actually is include math.h. So this is how the compiler knows where its header file is. The C file that we pass into the compiler is told, hey, my prototypes should exist in math.h. That's where you'll find them. So once again, Windows, yeah, you don't need to use them. You just want to know how they work. Perfectly said. All right, so let's write a functions. Throw me some function ideas that would make sense to belong in a math file. So, I mean, give me some examples. Square, multiply, yep. Let's be really sort of obtuse and be like, let's do multiply ints, for example. It's going to have to take int, x, let's call it int y, right? And it's going to return x times y. I know, really complex stuff, hey? But that's pretty good. Okay, don't get too crazy on me. So multiply ints, we could then do something like multiply doubles. That was a nice little edit there, do you agree? Bit of a flex. Now, okay, that's it. Now, what's different here about this program compared to most of the programs that we write in C? Okay, don't go crazy on the math. There's no main. Well done, Gabe. You got there first. Maths.c does not initiate an execution. Does that make sense? When we run this program, I mean, all we're doing here is writing these functions that we can use in our programs. But we do not have a main function in maths.c that starts doing it and printing it out. Where would the main function go? If I make this bigger, is it too small? So Matthew, you're saying in math.c, everyone else is saying in main.c. Yeah. Exactly, in main.c. So main.c is always needs to have a main function that accepts nothing, or it can accept something, and it returns 0. Right. That always generally belongs in the main.c file. But it doesn't, I mean, there's nothing special about this program, this file being called main.c. I mean, it could be in math. You're going to confuse me now with Matthew, but it doesn't actually matter. We're just being logical here. Nicholas, why do some libraries require main functions but others do not? So let me be clear. No libraries have a main function. By definition, libraries are useful functions for our program. A program always has only one main function because the main function is where the program starts. So a program can only ever have one main function. The main function does not need a prototype because it's where the program starts. Nothing starts running until we reach the main file, the main line. So there's no need to have a prototype. Main is not a library. That's correct. Main is a program that uses, math.h, for example. And that's the other place we need this math.h. We need to include that, we need to tell this main file that, hey, I want you to be able to look at math.h and, we haven't updated yet, and get all the functions that are available here. Main is the main character, absolutely. So main does not need to be defined anywhere. That's where it's defined. We'll need to include standard IO and stuff if we're going to do some printing, which we will. So yeah, we can include that. Oops. Oops. What have I done there? It doesn't like that? Oh, I forgot the hash. Excuse me. Apologies. Okay. Probably put that first. That makes more sense. So do the system includes, but it doesn't matter, but it's just more logical, I think. And then our library includes. All right. So what are we missing? Okay, we've got these two functions here for now. We can add more later. We need to put them and define them in the math.h. Whoops, something like this. That's it. That's all math.h is going to do, is going to have. Anthony, it's not stupid. Other functions cannot call main that I'm aware of. So the prototypes go into math.h. They associate and define what maths.c can do. Main.c includes math.h, which means I'm now able to do things that are defined in math.h. So for example, I can say int, my int equals, and it's, Visual Studio Code is saying, well, in math.h, here are the functions that are available. So I can multiply ints and do 2 and 5 or something. And then I can say printf %d my int and return 0. Cool. Daniel, somewhere there is a standard io.c file, but we didn't write it. It's somewhere. Yeah. All right. Do we want to run this and just to get a nice little proof of concept? Lots of questions coming up here. These are all really, really good questions. I promise we'll answer them. Let's just compile this. So GCC, what do we have to do? So we have to go the two C files that we need to include, dash out to a program. We run that, no error. We call the program and we get 10, which is the multiplication of 2 times 5. So that worked beautifully. Okay, I have the same question as Matthew. Where's Matthew? How does the system know that the function is in math.c when we only include math.h, which is a prototype? I mean, your question is brilliant. It doesn't. I can lie. Look, let's lie. Int, add ints. Int x, int y. Okay, here's this prototype add ints. Does math.c have an add ints function? No. My int equals, look, it's telling me I can call add ints. No errors here. When I compile the program, that's where we find the linking error. So when we compile, it first tries to do linking and it goes, okay, you've called add ints is here, then it tries to link it all together, and then that's when it's eventually said, it's tried to call it basically, and it's gone, hold on, I can't find add ints anywhere. I mean, I can't do this, and then it's going to get an error. But there's nothing wrong with sort of defining it this way. Is it still going to work properly if we have not separated the prototypes and then? So let's try that. I mean, we can try all of this. Let's not declare them in the function and try and compile. And again, we get errors. And the errors are coming in this time from the main file. So it said you've called multiply ints, but it's not declared anywhere. I can't do this. So you also get an error. I'm using VS Code, but it doesn't seem to recognize make sure the header files are in the same directory and with the same name, and you're including it in the C file. Nicholas, that's exactly well put. The point of this lecture is to help us understand that we can fuse, or the term is compile, multiple files into one program. We're generating one program called program. So we're not GCCing both programs, we're GCCing both C files. I'm getting an error. Why am I getting an error? Because I'm calling add ints, I think. So I'm compiling both of the C files into one program executable. So I'm creating one program. There's only one program here. And I call it, there's only one main, right? Only one program. But the program is comprised of multiple files. All right, as Tammy pointed out, there's been a lot of really, really good questions. Please, if we've missed your question, it's just an accident. Type it now. We're going to have a 5 to 10 minute break. We'll come back, do a quick Kahoot, and do more examples with the multi-file programs. Sound good? So please, if we've missed your question, feel free to retype it, and we'll be back shortly. Yeah, that's why it's called compile, Matthew. Exactly right. Okay, you summoned me, AR11. We're back. Where's the music? Oh, I gotta do this, I guess. Put that down. We don't need that too loud. How's that? Is that? Can you still hear me over the music? Gabe, there won't be lab exercises for this topic. That's what I meant. Okay. Patrick, tell me, did everyone's question get answered? There's some stuff I'll keep talking about when we go through the content. Can you include a header file in a header file? You absolutely can. It's not many of you that are joining. What's going on? Okay, you're coming in now. Valgrind. Where did that come from? Do assembly programs get called like C programs? Hold on, what are you asking there? Do assembly programs get referred to by C program? Yeah, they can. So a C program can execute an assembly program or embed assembly in its program. So game developers often do this to hyper optimize high impact functions. So basically some developers say, okay, well, this C file isn't being optimized into assembly well enough by the compiler. So I want to edit the generated assembly by hand. Some developers do that. Let's hide my camera. I'm sure I'll forget to turn it back on. All right, we ready to start? Yeah, then they make a 100 gigabyte game, so that's exactly right. But as long as the function's fast enough, then. All right, let's start. So what does a header file usually contain? Gabe, so usually they ship pre-compiled programs plus assets. Okay, wow, okay, most of you put function prototypes. So a few things go into a header file. So data declarations, data type declarations, function prototypes, and macros typically go into a header file. So that's the correct answer here. So I can include custom data types that will be in my header file because it's the declaration of the data structure or the data type, not the implementation. So, okay. But I mean, we've just covered this stuff today, so you don't have to be perfect. Okay, well done. Full stop. And then Audrey and Trey. Number 3. All right. We always need header files in our C programs. True or false? Okay, well done. 38 of you said false. That's correct. You can have a C program that is just one main.c file. Yep, well done. Okay. So C files and header files must be paired with the same name. I mean, this is a bit naughty because I just answered it quickly during the break in chat, but so if you're paying attention, you'll get that. So Tammy, I think I said to Gabe, I don't know if you heard me, but so typically you ship the compiled executable of the game plus all the assets, so images, audio, all of that stuff. But you might include source code separately. Okay, wow, or split down the middle. Yeah, not the case. So, and I'll show you how this works and what's actually going on. That's okay, Tammy. How that works and is going on. All right, looks like that was a bit of a brutal question. Oh, Joe's out. Oh, he's down. Was that you, Joe? Angry player, Jake Gonzalez, number 3. Okay. It's such boring names on the top of the letter. What's going on? C is the only language with header files. This is like a nasty question because it's like not really covered in the course, but bit of general knowledge. Uh-oh. Yeah, well done. I mean, I guess it's a bit of a guess, but C++ is the other programming language that heavily relies on header files. Yeah, exactly right, Krishna. Bit of RNG, you reckon? Player, okay. Is there one more or is that it? Last question. What is a valid method of including a header file? I'm not going to read these out. I'll butcher it. Okay, well done to most of you. Well, about a quarter. 17 said B. When do we use A? When we want to include a standard input, standard libraries. Okay. No one went for green. So, who's on the podium? Angry. Well done. Jake Mansella coming in third, clutch. And then number 1 is just going to be player. Well, congratulations to player. If you're a player, put your hand up in the chat. How do we verify it? We have no way of verifying it, and the points don't matter. Awesome. One difficult question. Cool. Well done, Krishna, if that was in fact you. Okay. All right. Okay. So, can the final exam be a course-wide Kahoot? Maybe it'll help with plagiarism if we did that. Yeah, everyone, yeah, congrats, well done. Okay, let's get back to it a bit. So some questions around, does the name of the header file need to match the C file? The answer is no. So I can do something like, let's just call this like, wow, that was a weird idea. Math2, right? Let's just change the name of it. Let's include Math2 because that's the name of the head file. And in main, let's include Math2. However, if you notice, Math2.h does not pair up with Math.c. Facecam, yes. Thank you. So Math.c does not, match the name Math2.c. If I go to the terminal and I compile like we've been compiling, that's all going to work just the same. And if I call that, program, that's going to work just the same. So it's not that the file name needs to match its header file, right? It just needs to point to where the prototypes live. In this case, it's in math2.h. Cool? But I mean, typically, it makes the most sense to just keep it all named the same. Basically, if I run through my understanding of how the linker works in the C compiler, it starts at the main program. It comes down. Anytime it finds an include.h, it runs to the include, scans it all, comes back and keeps going. That could be another include, and it's just like it's got like its own little piece of memory that it's storing all of the function prototypes and the struct types and custom data types that it's coming across in like a single reference. And then when it starts compiling it, it looks for them across the multiple files. But how it really works isn't too important. All right, so let me... what do we want to do here? Let's leave math.c, math.h, and the rest like this, because I think it's a nice, simple spot just to leave it. Do you all agree? Yeah, they're linked by the function name. That's correct. More so, correct. It's worth mentioning, you know, what do you think we do if we wanted a third file, like, you know, I don't know, anything. Math, I don't know. We could have, you know, linked list.c. Like, you know, if we got another set of header files and C files, we just make the header file, we make the C file, and then when we compile, we just keep putting them in. Logic.c, whatever it is. Whatever the names are called, if we're going to be calling them in the program, we just list the C files. Okay? Yeah, algebra, that's right. You can have specific files. Exactly. All right. Any conceptual questions on this stuff? If not, what I was thinking of doing... Okay, we've got two options. We'll do a poll. So in the meantime, feel free to post any questions. Do we want to break linked lists program into multiple files, or generic revision content? I guess, or we could discuss assignment to content, basically, probably linked. So I guess I'm speaking to myself. Why can't I ask the stream? What is going on? Must contain, okay, too many characters. This is rude of YouTube. Okay, that worked. Yeah, the options are way too specific. So what do we want to do here? There's probably going to be another cursed poll where it's going to be like a 50-50 split between... Oh, maybe not. Okay, is that enough time on the poll? Yeah, will it add up to 100? Exactly right. Bubblin's rallying some troops. Okay, no, that's a clear majority there. 70% assignment 2 content. Basically linked lists. Okay, so you're done with multiple files. You're happy with it. You're like, I'm not going to need to do it. Not interested. Move on. Let's go. All right. More linked lists. Well, you're going to need to tell me what it is. Why did all the viewers of the stream just disappear? Did something go wrong? Are you here? Can you hear me? Is this just a bug in YouTube? You're okay? Okay, I don't know. Are you going to have to tell me... I'm out of ideas for linked lists, so you're going to have to tell me what it is you want to focus on, which is fine. Let's get rid of this then. Minimize that. Close that. 29% not interested, yeah. So. So what do we want to talk about for linked lists? So some options. Do I need to do another poll? Let's do another poll. It's really, I mean, you do love the polls. So some options. We can whiteboard a function again. We can explain existing functions line by line. Oh, God, I like these short. We can write a new function. Bubbling, tomorrow a specific video will be updated on the channel, uploaded to the channel with assignment 2. The assignment 2 video is going up tomorrow. So I don't want to go too specific with the assignment 2. The lectures, it's more conceptual ideas, things we want to talk about. So that'll be uploaded tomorrow. So all of that, the video is already made, so I don't want to duplicate it. Okay, and now maybe we're going to hit the useless polls stats. All right, let's end that. Yeah, it's not live. Yeah, sorry. But we're going to have a forum post associated with it. Okay, so we're sick of the whiteboard. No, not really. Oh, actually, yeah, we're only 23% want to do the whiteboard. Maybe it's too slow or something like that. All right, 40% we can discuss functions line by line. Let's do that. I'm happy to do that. Yeah, so there won't be a live stream just because it's a lot of sort of administrative, not effort, but most people watch the video. So we're going to have the assignment video go up tomorrow. We're going to have a forum post for the Q&A. Whiteboard superior. I agree. I think the whiteboards, I don't know, for me, it's a good way of learning how it works, but it's good to do things differently. Okay. All right. Let's do the linkedlist.c version, not the crazy header file version. Sorry, the browser history version. Love your YouTube icon, Jay Huang. I don't know if it's much harder. I just think linked lists are more difficult. So that's what makes the assignment feel a lot harder. So, I mean, it's a later assignment. It's always going to be harder, whatever that means, but not because we're trying to be nasty, if that makes sense. Yeah, there's no obligation to watch it live, and then more people, I think, will do the Q. We'll try it out. If more people do the Q&A when it's on the forum, because it's async, that'll be good. All right. Krishna, what is the prettier? Prettier is a code formatter that does not work in C, so it does nothing. It's going to just complain. It's used for JavaScript a lot. Which you'll all do in COMP1511, which, if you want a bit of a insider, I don't know even what to call it, insider knowledge or something that I'll be teaching again in either term 1 or term 2 next year, which is exciting. So maybe I'll see a few of you then. I love 1531. So I don't know if I'm not doing it next term. I'm doing it next year. Yeah, sorry, Nicole. I just, yeah, sorry. But Hayden, who teaches it, he's teaching it next term. He's incredible. He's really, really good. So it's either way, you're sorted. Shout out to Hayden. Yeah, it runs every term. So yeah. All right. All right, what do we want to do? Do you want to pick a nice easy function, or do we want to pick a nasty function? I've got so many questions to you all. I should just outsource the lecture. Now, 1531 is an awesome course. And it's quite different to 1521, so you'll be easy. All right, let's do an easy one to start with. I agree. Let's do a nice one. Maybe print. And then we'll do the hardest one. We'll do both. Okay, print. So, all I want to do is the whiteboard, but you voted. I have to respect the vote. Let's start up here. Maybe I'll annotate it. Then maybe that's how we'll do it. All right. Can you read the comment? Is it, because it's gray, is it legible? Yeah, Hayden's, yeah, fantastic. And it's a group project in 1531. All right. So let's really do this. All right. We've got a function that's called print linked list. It returns nothing. So it's a procedure. It has one parameter. That parameter is a struct called node, which means if we go up here, we can see that this struct is made up of two things, an integer called data and a pointer, right? The asterisk means pointer, called next, which points to yet another struct node. And this is the crux of what helps us build up our linked list structure. So head is the name of the variable. It's a pointer to a struct node yet again, and usually indicates that what is passed in here, the head or the first node in our linked list. So we pass in, so if we had a linked list that was like A to B to C, what we're passing in the memory address of A. Okay? Any questions on that so far? It's funny with programming, you look at one, just the declaration of the function, and there's already, so many things that we can talk about and break down. All good so far? Betsy, what will happen if you use a pointer to a pointer to head here? Well, you could do it, but you would need to dereference it once. So we could do that here, but we would need to dereference the pointer and follow it once to get the actual value of the first node. Whoa. But we don't need to do that here, so we won't do it. Fun fact about double pointers like this. NASA, the American Space Agency, in their C code guidelines document forbid double pointers. So that you're not allowed to commit C code at NASA that does this. Their reasoning being that it opens up the opportunity for too many bugs in their C programs. And I suppose if you're sending rocket ships up into space, you're inclined to be more conservative with the code that gets shipped. So they have a bit more stringent C guidelines than most developers. So they would just work around it. All right. So we pass in the head, the first node. All right. We then make a new pointer, again to a node called current, and we say, read the memory address that was passed into head, make a new variable, and store the same address. So current is going to point to the same position in the heap that this first pointer was pointing to. So now we have in current, we're pointing to this function here, this node here, and then we've got inside of that node, we've got a pointer that points to B, and then B points to C. All right. Then we have this while loop here. And remember, this is printing the linked list. So the idea here is to access the first one, print the data, access the next one, print the data, access the third one, print the data, etc. The way we do that is by checking that the node that we are pointing to, for example, in this case, we're still pointing to the first one, has some data at the address it's being pointed to. So it's not pointing to null is what we want to check. If it's pointing to null, we're at the end of the loop. So while it's not pointing to null, okay, the memory, so it's saying, what this is saying is, while the memory address is not the null pointer. Because notice we don't dereference current. So we don't follow the pointer. We're just saying while the memory address is not null pointer. So it's not the memory address of the null pointer. Cool. That should be like that. There's nothing wrong with that, so I don't know what's complaining there. Yeah, there's just nothing wrong with it. Whoops. I think there's something slightly wrong with it. No, with the editor, maybe. Anyway. Okay, so if we're in the body of the while loop, that means that we are able to, we're not pointing to null, so we should have some data. What is current? Well, it's a node, a struct node. So a node has an integer called data and a pointer called next. Which means that we can use the arrow operator to dereference the pointer and access data. And remember, current to data is the same as dereferencing data, current, and accessing the data struct. This is the key thing to understand with the arrow operator. I was just testing something. Let me just delete this. Whoops. Nope. Okay. I was hoping that would fix that up, but currently it doesn't look like it did. All right. Then we have the final part of the loop. This is the same for sort of any loop we have, but we need to move to the next element in the linked list. Linked list. We do that by changing our current reference to be that of the address that next points to. Does that sentence make any sense? So now we're changing current to now point to wherever next was. Now that could be null, at which point the condition fails and we are at the end of the linked list. And that's printing the linked list. So remember dereferencing. We dereference with the star operator when we have a pointer. It follows the pointer to the memory, it follows the memory address to the location in memory where you actually have the integer and the other pointer. And then you can access the data there. However, because this is annoying to write, the arrow operator does the dereference for us and then accesses the field. Okay. Okay. All right. So it sounds like everyone's pretty happy with that. Now the hardest function. All right. Do we have one with the, probably one with the double pointer, I'm guessing. So with that one, when we point to next, what does that reference? So remember, what is current? Current is a pointer to a node. What is a node? It's got some data and it's got a pointer to another node. So next refers to the next node in the linked list. It's the memory address of where another node is stored in the heap. The next node in the sequence. But it's just a pointer to another node. Does that answer your question, Nicholas? Got it, no worries. Okay, perfect. All right, let me fix up some of these brackets. All right, do we want to do insert in sequence? This is probably the nastiest one. Yeah, I agree, Matthew. That's a really important thing to think about, is that it's just pure data manipulation, memory manipulation. Whew, okay, so this function is definitely stepping it up. So the idea again is that we've got this linked list. So for example, 3 to 5 to 10. We want to insert the node 6. So what we want is to have a linked list that is 3 pointing to 5, pointing to 6, pointing to 10. Right? We get the idea? So this data that we're inserting, this is the data that we're storing. We want it to be inserted in the position that we want it inserted. That's the idea behind it. So we can insert anywhere in the linked list, at the beginning, at the end, or in the middle. Because there are multiple ways we can insert this node now, so it could be at the end, like I said, or it could be at the beginning, or it could be at the middle, we need to handle those different situations, right? So naturally, functions like this are longer because they need to handle those different circumstances where we're adding it in the middle or the end or the beginning, because depending on where we need to add it, we need to manipulate the existing linked list in different ways. So these functions aren't any more complicated because they need to be. They're more complicated because they're doing more than one thing. They're doing insert at beginning or insert in middle or insert in end, depending on the location. Does that make sense? That's why they're typically longer. But they're all sort of doing the same thing. So let's break it down. Again, this is a case where we return, so where our parameters are the data we want to insert and a double pointer to head. Now, I've said this a couple times now. Why do we have to pass in a pointer to the linked list? Can you guys tell me? Or you can maybe confirm by typing it into the chat, and then I will let you know. When you say it, Bubbleen, what are you referring to? So the pointer doesn't change? Yes, can we be a bit more descriptive? Yeah, Nikhil's got the best verbiage of it so far. The pointer would right. In case we need to change the start, that's also the perfect answer. Yeah, so those of you who are typing it out have cracked it. So the reason we might need to do this is because you can imagine the circumstance. Why do we pass in a double pointer? Let's just call it that. Because we may need to change what the head pointer points to. So imagine we have a linked list of nothing, null, and we want to insert. Insert needs to change what head points to. And if there's no way of doing that if we don't pass in a pointer to a pointer, because once again, the value gets copied, we can change it, but it won't change it for the caller. Yeah, so when we did the poll, you said no to whiteboard. Whiteboards really help with this, but I'll stick to what you asked for. Okay, so the answer is because we may need to change what head points to entirely, not just add things to it, we need to pass in a double pointer. Yeah, I remember you saying that, Bubbly, and I'm with you. Yeah, okay. So, step 1, we need to have a reference to the current, never say no to whiteboard, agreed. We need to have a reference to the head of the linked list, just as we do for printing, with one difference, right? We want the pointer of head. So here we can just use head because head is a pointer. In this example, we need to dereference it once more so that we get the actual. So this dereferences head's double pointer once to get the actual pointer to the, that's going way too long. to the linked list. Yeah, if you want to draw the, that would be awesome actually. If you guys want to draw the diagram for this yourself, and then at the end, we'll figure out a way for you to send it to us, and I'll put them up. That would be a fantastic idea. Do we want to do that? So if you've got the energy and you think it'll be helpful for you, draw the diagrams up. We'll figure out a way for you to submit them. Maybe Tammy or Patrick can put together a quick form, and we'll display them if they're appropriate. Don't you worry. Okay. Do you want a second to get ready, or do you want me to just keep going? Doesn't have to be paper. You can do it online. Yeah, we do it on the forum. That's good. Yeah. No, now, Joe, you'll submit it like when I finish running through it. You can do it on the forum. We can get a post set up in the forum where you can post it. That sounds good. All right. We'll just let us know if you want to do it so that we know I'll slow down. All right. Tammy's going to make the post. Tammy's going to post the link in the chat. I'm going to give you all a second. This is what we'll do for the last 10 to 15 minutes of the lecture. So yeah, just give it a go. Give it a go. And I will tell you if I think you've nailed it, right? So it's a really good opportunity to get it checked. Just give it a go. What? I guess if there's 50 of them. But we can get other people to discuss in the chat. That would be good. Well, I will need to give you the input. So let's say that our linked list... You don't have to do it. No. You don't have to do anything, really, Nicholas. You are the lord of your own manor, so to speak. So let's say data is, let's say that it is 5. And the struct, and the linked list is the elements 2 pointing to 6 pointing to 7. Let's say this is our data that you'll be hand executing. Yeah, but it'll be on EdSTEM, but Tammy will post the link in chat when she's made it. So you just open up your whiteboard of choice. You can even do it on pen and paper and take a photo of it at the end. And then when the URL is posted, you can click it. And well, you can do that at the end. You don't have to wait for it. Yeah. Okay, but this is the data you'll be given. And I'm going to run through it line by line, assuming that this is our input data. So once again, head is a pointer to a location in main. Which stores a pointer to the heap for the first node. I'm really sort of spelling it out for you here, so that's good. Okay. And we're passing in, so we don't know the value of the pointer, and we're passing in the value 5. And this is what's in the linked list in the heap. That head is storing a pointer, which is pointing to this node here. Right? Because that's the head node. So that's what we're pointing to. All right, a lot of comments here. I don't know if this is good. Let's remove that. Let's remove that. All right. So we dereference the head pointer. We follow it down, and now we're in the memory. We have the memory address in the heap where this node is being pointed to, and we just make a new variable called current, which also points to the same location. We then set up a second pointer, which is called previous, and it's pointing to null. So that's those two lines. Setting up the 2 pointers that we need to do our sort of application here. All right. Now, let's think about it again. We need to iterate through the linked list, finding the right position, right? Data is 5. So, hold on. I get 5 is fine. Yeah, that's fine. Data is the value 5. So we know we we should return a pointer to a linked list which stores 2, 5, 6, 7. That's the goal of the function, right? Because 5 is greater than 2 and less than 6. Cool? So, but because we might need to iterate through the linked list to find the right position, we're always going to have a while loop. All right, I'm happy with that. I think that's just as good, a bit more concise. So we need a while loop. And we're just saying, basically, this is exactly the same as print. So loop through all the way to the list, to the end of the list. But however, we have this AND statement. So stop looping when you're at the end of the list. That's what this is saying. And also stop when my data, which is 5. Sorry, when this is the 5. When data is greater than the data at the node that I'm currently at. So, and alternatively, when my current node is less than my final node. So then data that's being passed in, sorry, not the final node. So at the first moment that we run this function, the first time the while loop runs, current.data is 2. So is 2 less than 5? Then we continue. That's true, so we continue. So we will loop one more time. So we'll loop to here, for example. So that's all that's happened now, and we run it again. So is the current node null? Well, it's not, because it's pointing to, it's pointing to something called 6, with 6 in it. And is 6, the current data, less than 5? And that's not true. So we've now found the position we need to insert the node. So we don't run the while loop, and we keep running. All right, only a few more lines left. So the linked list value is now greater than data, therefore we insert it, this is the key, after the previous node. So we basically loop until we're 1 too far. Because we're 5, right? So we're too far, we've gone over, we want to put it in the middle here. And that's why we need this previous pointer node, previous pointer, because we need to have the previous one and the current one so that we can change the previous one to have the node. And that's what this code does here. So we make a new node, okay? We call create node. I'm not going to run into what it's doing, but it's putting data, so 5, on the heap and telling it that its next value should point to current. We've seen this used many times. And we point to that memory location in a new pointer that gets created in the stack frame insert in sequence called new node. So we have this new reference to a new, this is what's actually called malloc and created the memory for the data value, the integer 5. All right, we've got an if statement here. So what's this doing? If the previous pointer is pointing to null. So what this is saying is, are we at the beginning of the linked list? Now, in this case, we're not. However, if we were, this is why we pass in the pointer. The pointer, we need to actually change what the pointer in main is pointing to, and we need to say, hey, you should be pointing to the new node. Otherwise, and this is our case today, where we're in the run through that we're doing, we're not at the beginning of the linked list. We've moved on to in this case, the second element. So make the previous node point to this new node. And remember, new node then continues to point onto the current node. And so we'll join up the linked list, and then we return the reference to head, which is unchanged. Right? That's why we have to make a copy of head, and we can't just use head to iterate. And that's the function. Okay, I don't know if that was too fast or too slow for those of you diagramming, but as soon as you're done, you can go to the forum. Let me open it. All right, no one's posted, but I mean, it's only been 5 minutes. But now I'm going to start answering forum questions while I'm going to get distracted. If there is only one pointer before head, what will happen? It doesn't matter if the diagram looks bad. That's completely fine. If there's only one pointer before head, well, I mean, that's what well, head should never have a pointer before it. But essentially, banner, we never know because we have no previous link. So we never know if there's a pointer or not before head. We never deal with it. Do you mean current or do you mean head? When would previous be null of the if statement? Great question, Krishna, and maybe this is what Banner's asking. Well, let's think about it. Previous is going to be null if we never looped and assigned previous. When will we never loop? We will never loop. Oh, I see your diagram now. We will never loop if current is null or if current's data is smaller than data. So if we should be inserting it, like if we were inserting the value 1, for example, the loop would never run, previous would be null, so we would have to change the first node. Does that answer your questions, hopefully? Yeah, that's exactly right, Windows. Well done. All right, we've got some posts coming in. Now, if you submitted a photo, are you okay with me showing it on the lecture stream? Yeah, previous is null, gets assigned up here on line 90. So previous will be null if this line never runs. What's the point of return head? We always try. Okay, good question. Good question. But when we pass in the double pointer, we don't actually need to do this, but it's just nice to point back to return back the head pointer. But it's a good point actually. This could just be void and not return anything because we're changing it in place. Oh, sorry. God. Remember, if we don't pass in the double pointer here, this won't work. That's the reason we do it. All right, so am I okay to show some of these diagrams? Or would you rather I don't? If you'd rather I don't, that's completely fine. Just let me know. I'll put one more comment here. I've got, this is the reason we pass in the double pointer, because otherwise we would be changing the copy of head in main, which, does this make sense? I know it's a tricky concept to get. I understand. Otherwise we would be changing the copy of head in main, which won't change in main or outside this function. Go for it. Okay, that's completely fine. All right. All right, so, oh, well, maybe we need a bit of both. And look, these aren't, we're not doing a roast here, right? It's, okay. So, bubbling, head points to this, which is a, okay. Sort of. Remember that in this case, head is a pointer to a pointer. So head actually points elsewhere. That location points to 2. So you're close. Oh, you can't see this. What am I doing? We're not doing a... No, we're not doing a roast. Please. Hold on. Can I just click this? Okay. Can I then do this? All right, that's nice. All right, so remember... that's right, you submitted something, so you're winning. So remember, head is a double pointer, so it's not true that there's only one line to follow. Does that make sense? Even though that is where it's eventually pointing to, it's pointing to an interim memory location, which then points to head. So that's just one small thing. Previous points to null first, then it points to here. That's correct. Current points to here first, then it would point to 6. That's correct. Then the while loop would end. New node would point to that. That's perfect. Previous would then point to that, and that would point to that. So apart from that very nitpicky thing where head is a double pointer, this is beautiful. Yeah, that's exactly right, Nikhil. That's what I've been saying. Yeah, well done. No, you're fine. That's fine. It's good though. All right, let's look at this. Can I make this bigger? No. Yes, I can. All right. Data equals 5. Linked list equals 267. Beautiful. Again, head points to something which points to this node. That's the key. That's why it's a double pointer. Previous. I like that you've got the next pointer and the value separately. Although then it would make more sense for this arrow to start up here. But okay, now this is turning into a roast. I'm sorry. Okay, first while loop is true. That's nice. Second is false. That's correct. So, I see. Black is the first. Okay, I like that. You've got some longitudinal encoding in this diagram. So black was going 2 to 6 to 7 to null. Beautiful. Okay, that's the other thing. This is missing that 7 points to null. But again, that's... On the second iteration, I think is what you're showing that what changed is that 2 points to 5, which points to 6, points to 7. Where's current, though? That's missing. Current and previous are missing. So, I mean, nothing's wrong, but it's missing. And again, it's missing that head points to something and points to this node. The only other thing that I would make clearer is that this node no longer points to this node. But I think you do know that. Whoever submitted this, I can't even see your name. Is that all we've got? Oh, wrecked. Only 2. Damn. Jay Huang, the something that head points to is it's in main, absolutely. Well, it's in the caller. It's whoever called it. It might not necessarily be in main, but in our examples, it's always been in main because we've called it from main. Yeah, 2 out of 60. Well, I know who's blanket passing the course. Bubbling and Nicholas. No, I'm just joking. All right, that is 5 p.m. That is the lecture. Please, we'll get the lecture form URL posted in the chat. But you can take a QR code. No, it's all right. I'm joking, everyone. It's okay, Jade. It's okay, Nicole. I know you can. Oh, by the way, you can submit it later. I just won't be able to talk about it. So please continue to submit it. Thank you, Patrick. That's awesome. So please, I always like reading the feedback, even though I know it probably gets repetitive. My experience surveys come out really soon. We'll talk about that next week. Yeah, that's right. Yes, moral support. That's exactly right. Okay, that's multi-file programs. Remember, you won't have to write multi-file programs in COMP1511. You definitely will in future courses. You could be examined on it, but again, you won't be creating it, so it could just be questions about it. What are we doing next? We're getting into the end of term now, guys, so it's up to you. So we've definitely got an we've definitely got a lecture on exam revision. We'll have a general revision lecture. Those will be in week 10. For next week, week 9, we have a lecture on another language. Again, not examinable, but I think it's really cool to see what you've learned applied in other programming languages, because software engineers and computer scientists, we do not work in one language. So that'll be really exciting. And we can do a poll and we could learn a new language together. I could show you my favorite languages. We could do anything like that. So we're going to be applying our concepts to new languages. And then we have like one free lecture. Essentially, we could do a few things. There's lots of things we could do. We could do revision. We could do some topics. I'm excited too. I'm really excited. We can be a bit exploratory now. So work on your assignments. Work on assignment 2. Some of you have already submitted it, which is amazing. Yeah, we'll have a movie day, Krishna. So we'll watch a movie. And then I'll get sued by YouTube. That'll be really fun. We can watch Hackers. That's my favorite computing movie. Has anyone seen Hackers? Angelina Jolie was in it. Isn't that incredible? You should all watch Hackers if... It's like a 90s movie. It's so camp, but it's so perfect. So only 7 students, Bobleen, out of 1,000. So yeah. You watched it on the weekend? That's incredible if you actually did. Or you're just manipulating me for clout. But either way, that's really good. Yeah, it's such a good movie. Okay. Okay, thank you all. Yeah, some people are... that's okay. Okay, you should start the assignment, but you're absolutely not expected to finish it. I didn't expect that either. All right, have a lovely rest of the week. Have a lovely weekend. Get excited about lectures next week. Assignment 2, sushi trains. When you finish assignment 2, you'll have to go to a sushi train. Yeah, it's a good movie. I should watch it again too. You've just... yeah. Thank you all. Thank you, Tammy. Thank you, Patrick. Thank you, everyone.